Hello dear friends, so welcome back to my channel. I'm Gerard and I'm here to revise differentiation. And so far we have seen what is a gradient, what is a tangent to a curve, and what is differentiation. And so differentiation is a rate of change um, of y in terms of x. So we say dy by dx or delta y delta x, given that delta x is very small or tend to 0 or indefinitely approaches 0. Okay, so we are done with this, and we came to the conclusion that for y is equal to x to the power of 2, the differentiation or the gradient this is a gradient, by the way, because we had y minus 2 divided by x squared minus, so which is delta y divided by delta x, the change. Okay, so we came to the conclusion that dy by dx is just 2x, and therefore we came with the power rule. The power rule is when you have xn, it becomes nxn minus 1. Alright, that's very important. We're going to use this to 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 work uh, to differentiate some more complex uh, equations. So let's say we have y is equal to 5 plus 4x 4. So if we want to differentiate this, it's very easy. So we have 5 times x to the power 4 plus, so 4 times 4 we have 16, x to the power 3. Because we have minus 1 here, remember again, it's if you have axn, y is equal to axn, the dy by dx is going to be a times n minus 1. So that's exactly what we have done here, and uh, it's good. So we're differentiating the first one and then the second one. We can say the first term and the second term. So easy. Even if you have two terms, you can differentiate one by one. And if you have something like that, we have seen this, 2x minus 5 to the power of 2, you have to expand it. You cannot just say 2x minus 5 and then that's it, because you have something inside. So let's say if you're smart, you say times 2, you'll have like 4 2x minus 5, which is like 8x minus 20. So we got 8x minus 20, but it's not necessarily true. So what we have to do is we have to expand what is inside. So we have 2, it's going to be 4x squared, and then we have 2 times, it's 4 20x plus 25. This is how we do it when we expand it by nominal, and here to differentiate we have 4 times 8 minus 20. I think that's exactly what we got from doing like 2x minus 5 times 2. We got 4 here, 2x minus 5. We got 8x minus 20. It's the same, but so we'll start by expanding this. But if you know chain rule, this is another rule. We have seen power rule, we have seen terms by terms. This is chain rule. We're already getting chain rule because we have to multiply by the differentiation of what is inside. So we differentiate this and that. Okay, so when you differentiate a constant, it just go away. This is something that we saw. So for example, if we have 4x minus 20x plus 25, when we differentiate, we'll have 8x minus 20. This just go away. We just make it go away because it's a constant. And because the differentiation of a constant is 0. A constant does not change. And by definition, first divide each term by. Well, here we have a complex one. Let's try this. Y is equal to 3x to the power of 6 plus 8 divided by x to the power of 2. So here looks very complicated. How can we differentiate this? But we can rewrite it like this, divided by x squared plus 8 divided by x squared. So if we put this up, we have 3x. We have to minus this. It's going to be 4 plus 8x minus 2. Alright, so we came to this, and so now we can differentiate it because we don't have how do you say, a fraction. We don't have a ratio. We have just something we know. So we just go term by term, first term, second term. So the dy by dx here is going to be 12x3 plus, now it's going to be minus 16x minus 3. Later on we can rewrite this by putting the x down here. Alright, so this is simple. And another example of differentiation when it looks complicated, but it's really not. You can find something like 24 root cube of x and minus 1, 2 root x. All this looks awful. How can we differentiate this? Well, this is not dy by dx already, but this is just y is equal to this. You have the function like this. So let's try to rewrite this. We have 24 times x power cube minus, we have half, and if we put this up, we have minus half. This is something we know. This is a constant, this is a constant. So it's not going to change, because these are constant. So if we do the dy by dx, we'll have 24 times 1 over 3, and that's going to be minus 2, 3, and the other part will be minus half times minus half is equal to x minus 3. So that's what we have. And if I will erase here, make some space, so let's rewrite this. So what do we have here? We have 24 sorry, on 3 x to 3, and this times this, you get plus, and you have 1 over 4, and you have x 3 over 2. So we can rewrite this in terms of 3 root cube of x squared plus 4 root cube of x squared. I think they're both the same. No, not the same, because here it's 3, here it's 4. But we can divide this, we can put this 8 here. Yep, so that's the answer for it. So it's not so hard after all. It looks very daunting, but it's not really. So this is about going term by term, and if you have something in bracket like this, you can just expand it and go term by term, term by term, not to make mistakes. But now we'll get smarter, and we're going to tackle the chain rule, which will simplify your life, not to expand these things all the time. Okay, so how do we do this? Chain rule, guys. In chapter 2 we dealt with composite function, and if x is star, then so basically we had for solving a quadratic equation, for example, if we have y is equal to x6, x to the power 6 plus what, plus x to the power 3, so we can just say y, no, we don't have equal here, it's just this expression, this is a quadratic expression. We can say that this is a substitution for this. We'll get therefore y to the power of 2 plus y, and we can solve this easily. So for example, if this is equal to 0, we'll just say y here plus 1 is equal to 0, so y is equal to 1 and y is equal to minus 1. So we have the solution set for this, but remember that we did this, so if 0 is equal to x to the power of 3, so root cube of this, so x is going to be 0, but for this one, if it's minus 1, so root cube of minus 1 does not exist. I will check this immediately. Shift. This does not exist, I think. So minus 1 root cube of minus 1. Normally, a root of something minus is not possible. It should be greater than 0. So yeah. So yeah. If I square root minus a negative number, it gives me an error. But if I root square cubic root, I don't know. Let's see. Wait. I have minus 1. I want to. It's not working. Let's say I have this, and I want to root cube it. No. Yeah, that was already root cube. Okay, guys. Okay. I haven't been using my calculator for a long time. Root cube of minus 1 is minus 1. Yeah, so it's going to be minus 1, sorry. Because if you have minus 1 times minus 1 times minus 1 is going to be minus 1. So this is this. So we still have to two roots. Okay, that was what we've learned before when I did quadratic equations and inequalities. So now we are going to do to use this knowledge for the chain rule. The chain rule. And so if we have, for example, y is equal to, or let's say not y, but fx is equal to x to the power of 7, and gx is equal to, let's say, x to the power of 2, 3. So we have an expression here. So then we can have f gx being f of x, which is the same as x squared minus 3, 7. As you can see here, we have put one function in another function and we've got this. This is a little bit what we, what we did before when we put y in terms of, in the function of the first function. So we created a second function to substitute it in the first function to ease our job. So a function can be in another function, and we use the chain rule to solve such problems, complexity. So now let's look at an example. So y is equal to x squared minus 3 to the power of 6. Let's say to the power of 7, just to be the same as in the book. So u is equal to x squared minus 3, and y is equal to u to the power of 7. So exactly, we have a first function, a second function. So this function is inside of this function, yeah, and we get this. So we have broken this into two, okay, so that we can work with them more easily. So here we can say du by dx. Du by dx is going to give you 2x, and dy by du is going to give you 7u to the power of 6. So now if we have du by dx and dy by dx, we can find dy by du, sorry, we can say du by dx multiplied by dy by du. It gives you dy by dx. So we have these and these, so we just have to multiply. Remember that u was this. If we replace this to the power of 6, I'm taking it from here, but I know that u is equal to this, so I got this here, and multiply by 2x. So in the end, I can erase this. Sorry, can erase this because we have what we wanted. We have that dy by dx is going to be 14x, because here we have 2x times 7, 14x, and here we have x squared minus 3 to the power of 6. Alright, and so this should be the answer, and it is. So this is chain rule. You do one and you do the second one here. Two functions. We break one function into two functions, and then we can do like that. dy by dx is equal to du by dx multiplied by dy by dx. This cancel, we get dy by dx, dy by dx, and voila. So that was chain rule. Chain rule is just dy by dx is equal to dy by du multiplied by the du by dx. That's it. All right. So let's do an example. Let's take something at random. Y is equal to root of 4x minus 1. So we want to differentiate this. We can write it like this, half, because we know that we want fractions, we want numbers, and so on. Now we have this and we have this. We can say u is equal to 4x minus 1, and so we have u sorry so u is equal to this, so y is equal to u to the power of half. So we differentiate this, du by dx, we'll have what? We'll have 4 dy by du, we'll have half u minus half, and if we multiply both, we will get dy by dx. We already saw that, so it's going to be 4 divided by 2 root of u, because I'm sending this down, so yeah, so it's going to be 2 here. So this is the final answer, 2 over u. We have to replace u, so just to erase everything here, it's very easy. You have seen how quickly I am doing with this. So dy by dx is equal to 2 over whatever was u was 4x minus 1, and yeah, the original was this expression given. So if we differentiate, we get this. Yeah, so this is chain rule. This is chain rule, guys. And let's just do one last, just to make sure that we got it. So we have y is equal to 1 plus root x. So how do we solve this? Sounds difficult, right? So if we break this, we have 1 over, can we break this? Let me pause this, I have to think about it. Okay, I will just have an attempt. What about this minus 1? I can just say it's minus 1, right? And I can say also that u is equal to 1 plus x to the power half, and that u minus 1 is equal to, sorry, and that y is equal to u minus 1. Yep. So if I differentiate du by dx, I will get half x minus half. And if I differentiate dy by du, I'll get minus u minus 2. So if I multiply this by that, I will get dy by dx. So dy by dx is going to be half time what is u here? Because it's minus, u is 1 plus x root, yeah, mm, to the power of -2. So that's what I have. I'll just erase here. I will rewrite it. Yeah, going to rewrite it. So dy by dx is equal to, this one I will have to check in the book what's the answer. Just, because it's quite challenging. 1 plus power of 2. That's what I have. That's what I have. And I will pause, look for the answer, and I will come back. So guess what, guys? This is correct. So I've just mastered chain rule. Well, thanks for watching, and I hope that you got the hang out of it as well. Remember, chain rule is just, let me rewrite what is chain rule so that you also remember that chain rule is just dy by dx. You can get it by differentiating du by dx and dy by d times, this is multiply dy by du by dy. Yeah, so one second, it's dy by du, sorry, it's dy by du, because this will cut in this and you will get these guys. Alright, thank you so much and have a nice day. That was chain rule. Thank you, bye.